I'm going to talk to you about all the different number sets that you'll use through pre-calculus. Every number you're going to deal with in math is called a complex number. I'm going to create an upside down tree with branches showing you the different types of numbers. A complex number will take on the form a plus bi, where the a part is the real part of the complex number and the bi is the imaginary. So for instance, 5 minus 2i is a very nice looking complex number. 6 plus I. Negative 3 minus 4i. It could be fractions. 2/3 plus 1/6 I. Okay, it can be decimals also. Complex numbers break up into two different branches. We have the real numbers that you're very familiar with and the imaginary numbers. Real numbers are numbers like 5 plus 0i, but we would just say 5. So numbers that you're used to. 2/3, the square root of 4, the square root of 9. I could have used those in the complex numbers also. 1.8 decimals, negative 16, sign numbers, 0. Most of the numbers you've ever dealt with are real numbers. Imaginary numbers is a very simple class. It's just your i's, your negative 3i, your 7i, numbers like that. And that branch doesn't continue. The reals, though, do continue. We have two different branches with the real. We have our rational numbers. Rational numbers are numbers that can be written as fractions. And we have our irrational numbers, numbers that cannot be written as fractions. So all of your fractions, 2/3, 1/8, automatically rational. Numbers like 5, that's a rational number because you can easily write it as 5 over 1. Negative 8, you can rewrite that as negative 8 over 1, so that's a rational number. Decimals like 0.3, that can be written as a decimal, as a fraction, 3/10. Decimals that repeat, such as 3 bar, that's 1/3. Decimals that repeat can always be written as rational numbers. Irrational numbers are pi. The square root of not 9, the square root of 90. It's a terrible example. The square root of 5. Square roots that do not work out nicely. Square roots that do work out nicely, like the square root of 4, you can change that to a 2, which is 2 over 1. That's a rational. Euler's number on your calculator, you have an E. And when you type out that button on your calculator, it'll look like it repeats, but after your calculator screen, after you see that last digit, after that the numbers go crazy, just like with pi. So these are examples of irrational, not a very big set. Rational numbers don't branch, they just get a little bit more specific. Inside the rational numbers, you have your integers. Integers are your sign numbers, no fractions. Your sign numbers, negative 5, negative 3, 0, 18. Numbers like that you can do on a number line. Inside the integers, you have what we call the whole numbers. Whole numbers are your numbers that are not negative. So 0, 1, 18, 5. These are your whole numbers. And a little bit more specific, inside the whole numbers, we have our natural numbers. And natural numbers are your whole numbers except for the 0. So 1, 2, 3, 18, and so forth. Numbers like that. You should just go back and study these examples that I've given you. What I've done here is I've written out some numbers and I'm going to put them in the correct sets that they belong in. Some of these numbers are going to belong in more than one set, such as 0. 0 is a complex number. Everything's a complex number. It's a real number. It's not imaginary. It's a rational number. It's not irrational. It's also an integer, and it's a whole number. 0 fits in several sets. 5 is a complex number. It's a real number, it's not imaginary. It's rational, it's not irrational. It's an integer, it's a whole number, and it's a natural number. -8. -8 is a complex number. It's real. It's rational, because I can easily write it as a fraction. And it's an integer. 3/4. 3/4 is a complex number. It's real. It's not imaginary. It is a rational number. It's already in the classic rational number form. It's a fraction. And that's all that it is. Pi. Pi is a complex number. It is real. And it is irrational. It's a decimal that goes on forever with no repeating pattern, cannot be changed into a fraction. 7i. 7i is a complex number. It's also imaginary. Negative square root of 9. Negative square root of 9 is the same thing as a -3. -3 is complex. It is real. It is rational. And it is an integer. Square root of 10. Square root of 10 is complex. It is real. It is irrational. Square roots that do not work out nicely are always irrational. 1.5. 1.5 is complex. It's real. And it is rational because I can rewrite 1.5 as 1.5. And that is it. Study these examples. Hope you learned something.